that you start to see when you're solving equations is that sometimes you need to cancel things out. And so this right here shows you that certain operations cancel each other out. So turn to page 84 in your books. We're going to start on section 1, solving equations by adding or subtracting. By adding or subtracting. The first thing we're going to talk about is what is an equation, all right? Very simple. An equation is a sentence, a math sentence that has an equal sign. If it doesn't have an equal sign, it is not an equation. It is a statement, but it's not an equation. It has to have an equal sign to be an equation. A solution is a number that when you put it into an equation, it makes it true. All right? If it doesn't make a true statement when you plug it in, it is not a solution. All right? And then inverse operations are operations that undo each other. And that's what we saw in bell work. We saw operations that undid whatever was in front of it. Those are called inverse operations. Inverse operations. And so they give you this example. Addition and subtraction are inverse operations of each other. Because if you add and subtract the same number, you get where you started. Okay? And so you will always get the original number. Add 7, subtract 7, you get the original number. It's going to end up 15 like it is right there. And those are called inverse operations. They undo the inverse operation, all right? And so this is how we solve equations. We have to look at one property before we can solve equations. This is called the addition property of equality. All right, and they use all these variables, which is fine. A, B, and C are just numbers, all right? And they tell us A equals B. So you have a scale and you have A equal to B, all right? What this property tells you is if you add something to A, in order for that scale to remain the same, you have to add that same thing to B, okay? Which makes perfect sense. If you are weighing something and you put weight on one side, it's going to go down. In order for it to remain the same, you have to put the identical weight on the other side. And that's how equations work, all right? Whatever you do to one side, you have to do to the other. And that's this property of equality. So we're going to start with solving, basic adding and subtracting, solving equations, and then we're going to check our solution. So this equation that they gave us here is x minus 6 equals 10. Now what you're going to find with some of these is that you can do these in your head. So why am I going to show all the work? Because there will come a time when you cannot do this in your head. All right? And so the goal here is to build it a little bit at a time so that when you get to the point where you can't do this in your head, you know the steps to do it. All right? So we have the equation x minus 6 equals 10. The goal of this is to always keep them balanced, right? But the ultimate goal is to figure out what x is. So I have to get x completely by itself in order to figure out what it is. Once x is completely by itself, I know what x equals. Right? And so I'm going to look at what is happening to x. I'm going to say, well, right now, x is subtracting 6. I can see this. X is subtracting 6. All right? So what we need to do is we need to keep this equation balanced, but we need to get rid of 6. We are going to do that by using the inverse operation. So right now we have a subtraction. What is the inverse operation of subtraction? Addition. So if I am subtracting 6 here, then in order to get rid of 6 or to reverse that operation, I need to add 6. But this is an equation. I cannot just add 6 to one side and keep it equal. What do I have to do? I have to go to the other side. So since I added 6 here, I have to add 6 there. Now that I've done that, you're going to see that this negative 6 and this positive 6 are inverse of each other and they cancel. They become 0. Well, x plus 0 doesn't change x. X minus 6 plus 6 kept an x, right? Just like 15 plus 7 minus 7 was still 15. So we have x minus 6 plus 6. I still have x. That's all that's left. One of the things you need to remember to do when you are solving equations is you need to bring down this equal sign. Some people forget that there's an equal there. You need to bring down your equal side. On the other side of this equation, I have 10 plus 6. That's rather simple. What is 10 plus 6? 16. So I have solved this equation and my answer is x equals 16. Now remember I said in order to be a solution, I have to be able to put this back in and make a true statement. If I put it back in and I do not get a true statement, this is not the solution. And so what I need to do is I need to go back to my original equation up here and I need to plug it in. So instead of x, I'm going to write what I'm saying my answer is. 16 minus 6 equals 10. Is that a true statement? Yes, it is. This is my answer. All right. All right, so for this one, I have a plus 39 equals 17. A plus 39 equals 17. So my first thing to do is to figure out what's happening. Well, what's happening between the a and the 39? What is that operation? It's addition, right? So I know that I have addition going on, but I need to use the inverse operation to get rid of it. What's the inverse operation of addition? Subtraction. So I have addition here. My inverse operation is subtraction. So I'm going to subtract 39. All right? And because I subtracted 39 on the left, this is an equation. I have to keep it balanced. I must subtract 39 on the right. Okay? Now on the left-hand side, I have a plus 39 minus 39. What do I have? I have a because these actually cancel each other out. I have a. Remember to bring down your equal sign. Now on the other side, I have a little bit of a problem because I have 17 minus 39. I will tell you that from algebra to calculus, I have kids that just do not like positives and negatives, okay? So if you're one of those kids, that's perfectly fine. You are with everybody else. Most people don't like this rule. But here's the thing. I have one positive number. My positive number here is 17, right? I have a negative number. My negative number here is 39, all right? So anytime you have a positive and a negative number here, and you're adding, that's basically what we're doing, adding or subtracting, you need to just subtract the two numbers. So what we're going to do is we are just going to take 39 and we are going to subtract 17, okay? Because I have one positive and one negative, which means those two values are going to subtract from each other, all right? So if I do this, this is pretty simple. 9 minus 7 is what? 22. Yeah, it's 2 and 2, right? So I have 22, but which one was the bigger number? Which one was further away from 0? My positive or my negative? My negative was further away from 0, right? Everybody understand the question? All right, so I'm at 0, right? If I am going, and I always have to do opposite because y'all are opposite of me. If I'm going into the positive 39, in the positive 17 and into the negative 39, my 39 was further away from 0, okay? So that's how I know what my answer is going to be. The one that was further away from 0 controls the sign, okay? My 39 was further away from 0 and it was negative. So my answer here is going to be negative. All right? Think of it as movement. If I have any football fans, that's my favorite sport, okay? So what did we do here? We first said, this is addition. That means my inverse is subtraction. Because I subtracted on the left-hand side, I must subtract on the right-hand side. And then I just do the number crunching. All right? Talk through this one. So we have x plus 18 equals negative 46. I'm guessing most of you knew to subtract 18, right? Add 18, so my inverse is subtract. Subtract 18, subtract 18. All right? Most of you probably knew that if I have x plus 18 minus 18, I should then end up with x. Here's where most of my students have questions. All right, I have a negative 46 and a negative 18. Are these moving me in the same direction or different directions? The same direction. So I just need to add them. All right, I just need to add them. If they are moving you in the same direction, you add. All right, so if you added these two numbers, you should have gotten 64. However, what direction were they moving you in? Negative or positive? Both negative. So this was negative 64. All right. If you owe $46 and then you owe another 18, you owe $64, right? Does that make sense? And so if they are moving you in the same direction, add and just keep your answer the direction both of them were. All right? 6 was probably a little easier. You should have added 25 to both sides. You had 87 plus 25, 112, right? 7. 7 is set up a little differently than the ones that we've looked at. 7 has 125 equals S plus 87. And we're going to talk about this actual thing in just a second when they're on different sides, which is fine. It does not matter which side the variable's on. For this one, you should have subtracted 87. And once again, it was basic subtraction. 125 minus 87. 25 minus 87. This last one, 8. All right, for this one, were they moving you when you finally got to your answer? 162 equals C minus 48. My operation here was negative subtraction. So my inverse was to add. Are these guys moving you in the same direction or different directions? Different directions. You should have subtracted here, right? Subtract 162 and 48. You would have gotten 114. Which one moved you further, your negative or your positive? Your negative. Your answer was negative 114. All right? Symmetric property seems pretty straightforward, but it's actually really important when you're solving equations. This just says if A equals B, then B equals A. That makes perfect sense. I mean, obviously, right? But why does that matter? Because sometimes, seriously, when you're solving an equation, it throws you off when the variable's on the opposite side, all right? And so you are free to rewrite it, always. If you always want your variable on the left-hand side, you can immediately flip them. Now, there are going to be times when they're on both sides, and that's a little bit further in the book. But if you have it like this, and you have 47 equals m plus 3, you are perfectly fine to flip those. And you can say, well, I want to do it this way. M plus 3 equals 47. That is the same thing, because if 47 equals m plus 3, then m plus 3 equals 47, right? And then I have something really easy to solve. What's my operation here? Addition or subtraction? So what's the inverse? Subtraction. And then I have something really easy. Obviously, on the left-hand side, I just have my m, bring down my equal, and then this is 47 minus 3, so I have 44. You can check it. If it checks and it's a true statement, then you had the right answer. All right, 2 more types of problems, and then we're going to do some solving. Look at example 4. All right, so here we have an equation that is written really oddly. They have y minus a negative 7, all right? Minus a negative 7. So typically subtracting would move you it back, right, on the number line. But now I'm subtracting a negative number. And so when I subtract something, it's actually adding the opposite. That's actually the definition of subtraction. Definition of subtraction is adding the opposite. And so when I have something like this, I do not want to start solving it yet. I want to simplify it because this is hideous. I don't want to solve it like this, all right? And so I want to change this guy to adding the opposite. If you have a minus minus, go ahead and make it a plus, all right? Because it's going to make your life easier here. So when you are subtracting something, you're taking it back, but then you flip it because it's a negative that you're taking back. And so then it moves you forward. So it's just a weird concept of subtracting something that would normally move you the opposite direction. You're doing the opposite. And so subtraction is adding the opposite. So I'm going to change this instead of y minus a negative 7 to y plus 7. All right, y plus 7. And then all of a sudden, this looks a little nicer to solve. So my operation here is what? Addition or subtraction? Yeah, so my inverse, right, is going to be subtraction. Are these moving me in the same direction or in different directions? The same direction. So what do I do with them? Add or subtract? I add them. They were both moving in which direction? Positive or negative? So my answer is negative. All right? My answer is negative. And I can try this. I can plug this back in. If I have negative 25 plus 7, does that equal negative 18? Well, these are opposite directions. Negative 25 and 7, and where? All right. Example 5 is written like this: z plus a negative 32. This is a really weird way to say subtract, right? When you add a negative, you are subtracting, right? And so if I said 10 plus a negative 3, that's the same thing as saying 10 minus 3. And so when you're solving equations, you don't really want to write it this way because it looks crazy. We're going to rewrite it and say z minus 32. It means the same thing, and it makes it much easier to see what I need to do there, okay? What I need to do is I need to do the inverse operation. So now you can clearly see that the operation that's actually happening here is subtraction. And so my inverse operation here is going to be addition. And so I am going to do that, add 32 to both sides. On the left-hand side, I'm left with just my z, right? Bring that equal sign down. Add my 19, and I think I wrote it should be a negative. Negative 19 and 32. Are they moving me in the same direction or opposite directions? Opposite directions. So I'm going to subtract 32 minus 19, right? And I'm going to get what answer here? 13. Which one moved me further, my positive or my negative? The positive, so my answer here stays positive. All right? Questions? So now go ahead and do the skill check. All right, so this first one, n minus a negative 28. We really need to simplify that first, right? We need to simplify that first. So how do I simplify it? I make it, instead of minus a negative, what do I make it? Addition. So you can rewrite it like this. And then what is my inverse operation there? Yeah, subtract it. And so when I subtract, I should get 45. 45. Now the other ones, you could have just solved them the way they were, or you could have flipped them. Meaning, if you wanted to, you could rewrite it, v plus 34 equals 115. And r minus 69 equals 98, right? You don't have to, but if you prefer always having your variable on the left, you can rewrite them, all right? Either way, the inverse operations are going to stay the same. For this one right here, I am adding. So what is the inverse that I need to do there? Subtract that 34 from both sides. You should have gotten 81, all right? 81. For this next one, it is subtraction. What's my inverse operation there? Addition. You should have added 98 and 69 to get 167. 167. So for number 3, I have plus a negative 41. How do I rewrite that? M minus 41. Since I am subtracting, what is the inverse operation here? Adding 41. Since I add it to the left, equality says I need to add it to the right. On the left, I get just an M. These are moving me in the same direction, so I'm just going to add these two, right? When I add 87 and 41, I get 128. They were both moving me in the positive, so it stays positive. All right, this is the problem-solving kind of guidelines. This will be true all the way through math. This will also be true in science when you're doing problem-solving in science. So this is like the step to solving a problem. Read the question to understand it. So if you do not read the question, there's no way you can solve it, right? That's just logic, okay? If you don't read the question, you don't know what they're asking. So you have to read it to make sure you understand everything that they are giving you and everything that they want you to give them, right? The next thing you're going to have to do is plan how to solve it. So algebraically in this class, that means maybe rewriting it with numbers and pluses and minuses and all that good stuff, right? In science, it may be, okay, I'm in chemistry and I need to figure out what to put here and what to put there. There's a plan to solve this problem, all right? Write an equation. So once you figure out how you're going to do this, you're going to write an equation. Solve the equation, which we've just talked about how to solve equations. Then you want to check and make sure it's reasonable. Why do I say make sure it's reasonable? Because there are going to be times when you have word problems and they are asking you for time. If you get a negative answer in hours, you probably did something wrong. They don't expect you to time travel. So if they say, how many hours did it take to drive to Columbia and you got -7, you did something wrong. So you can logically say a negative answer doesn't make sense here, right? Even though a negative answer, if they were asking for temperature, might make sense. Let's say they're asking for speed of a boat and you get something like 400 miles an hour. Unless you are airborne in the boat, you did something wrong. That's not a logical answer for traveling in a boat, right? And so that's why that last thing is there, because you could solve all this and think you did everything right and your answer makes 0 sense in the actual setting that they gave you. And so that's always going to be your final step. Does this make sense, right? And one way in algebra you can say, does it make sense, is you can plug it back in, okay? So the first thing we're going to do is we're going to do basic converting expressions to numbers and symbols. So write each word or phrase as a mathematical expression. Use n for variable. That's what the book is telling you. I will say when you start doing word problems, you can set your own variables. So if you're looking for something, you can set a variable that makes sense. I will just recommend certain things you don't want to use. You don't want to use something like O as a variable. Why not? 4 more than a number. If I am saying 4 more than a number, am I adding to that number or subtracting from that number? I am adding to that number. So I am taking that number and I am adding 4. If it's addition, does it matter what order I write it in? No, it doesn't. 2 plus 3 equals 3 plus 2, right? A number increased by 10. Am I adding or subtracting there? Adding. 5 less than a number. Right, so it is subtract. Well, you have to take that number and you have to subtract 5 from it. A number decreased by 7. Addition or subtraction? Subtraction. They take the number and they decrease it by 7. All right? And then this last one says 17 decreased by a number. Now we're going to say 17 minus the number. You can see right here, none of these are equations. How do I know these aren't equations? What is it missing?
Equal sign.
From the very beginning, we said it's not an equation if it doesn't have an equal sign. And so look at example 7 here. This says write an algebraic expression. Expression means you will not have an equal sign, right? Then we're actually going to do one that says equation, all right? So if it says expression, you're not going to be able to solve it, one, because there's no equal sign, and you shouldn't have an equal sign because it's just an expression. So all of the things we just did in example 6 were expressions, and that's what they're wanting. They're saying write an algebraic expression for the number of nickels Sergey has and the number Kimberly has. So we want to write an expression for Sergey's and for Kimberly's. And it's just going to be an expression, all right? Sergey has 8 more than Evan. Do we know how many Evan has? Did they tell us? No. So we're going to use something for Evan to represent his amount. What are we going to use? X. We're going to use some type of variable. So we say X, okay? So Evan's amount equals X. So if Sergey has 8 more than Evan, how are we going to write Sergey's? X plus 8 or 8 plus X, correct. Kimberly has 6 fewer than Evan. So how are we going to write hers? There we go. All right, those are expressions. All right, can we solve for it? No, we do not have enough information to solve. They didn't give us enough information to figure out how many coins we have. All right, this is an expression. So let's write these expressions. Now these instructions are a little bit different. The last set of instructions says write an expression. This one says write what? An equation, which automatically means I'm going to have an equal sign in it. All right? And so keywords here. All right? Anytime you see the word is, that is where your equal sign is going to go. All right? It is literally saying this side equals that side. Whatever's in front of the is equals whatever's after it. All right? Is the representation of your equal sign. And so you are going to interpret this, a number decreased by 3. That's an expression that we have done. Is, we're going to say equals, and then they give you a number written out. Okay? So my first thing, decreased. Am I going to be using addition or subtraction here? Subtraction. A number is being decreased by 3. How am I going to write that? N minus 3. And then they have this is. That's where I'm going to put my equal sign. And what is it? It is 16. And so I have a very simple equation that hopefully I can solve. How would I solve it? If my operation subtraction, what am I going to do? The inverse, which is addition. right. When I add it, I get n on the left-hand side. What do I get on the right-hand side? They're moving in the same direction, both positive. My answer is positive 19. Okay, look at the next one. Next example. Write an equation. I automatically know I'm going to have an equals sign. For the sentence, $7 more than the cost of the shoes is $98. What do I not know in this sentence?
The cost of the shoes.
The cost of the shoes. That is where my variable is going to go. The cost of the shoes is going to be my variable, whatever variable I choose. $7 more than the cost. How do I write that algebraically? Addition or subtraction? Addition. So I'm going to say 7 more than the cost, or because it's addition, I can say C plus 7. Either one is the same, right? That's going to be my equal, and 98. Now, I wrote this differently than the book. My number is first, all right? Is that 7 positive or negative? It's positive, right? Even though you're going to subtract it, yes, but right now it's positive, okay? And so when I am looking at this, I actually don't care what happens after the 7 to decide what I'm going to do. I actually care about what happens before the 7. And I say this because sometimes they'll write it in this order, okay? So if I know this is a positive in front of the 7, how would I solve it to get rid of it? What's the opposite of the positive? So I'm going to subtract it to solve it, okay? And so had that been negative 7 plus C, I don't care that it's a plus C, I care that it's a negative 7. And I would have added it to get it across there, all right? So you're always doing the opposite of what that number is. What am I going to get here? Are they moving in the same direction or opposite directions? Opposite. So 98 minus 7 is 91. Positive or negative? Positive. Would it have made sense to have a negative number here? No. Why? Talking about the cost of a shoe. How many shoes cost negative dollars, right? Does that make sense? And so I want to say, does this make sense? It does. All right, go ahead and solve these. It says write an equation. I actually want you to go ahead and solve them. So write the equation and solve them. The sum of a number and 18. Addition or subtraction there? Addition. So you should have said some number, whatever variable you chose, plus 18 equals 31. And so your inverse would have been to subtract 31 minus 18, and you would have gotten what? 13, right? 13. 31 minus 18. Yep. All right. 23 less than a number. You should have had your variable first minus 23. So what is your inverse operation? Add 23. Your number was 29, right? 29. $8 more than the total electric bill. What do you not know here? Well, you don't know the total electric bill, right? So that's your variable. 8 more than that would have been addition equals 76. And for this one, order does not matter, right? Subtracted over, what was your electric bill? $4. Subtract your 8 over 76 minus 8. 68, right? Subtract your 8 over. Subtract your 8 over. Now this last one's a little bit tricky. The total bill was 18, all right? The total bill was 18. So if I add up everything I bought, I got 118, right? What did I buy? Shoes and a dress. What do I not know? The dress. So I'm going to put a variable for the dress. If I add that to my shoes, I should get the total bill. What's my shoes? My shoes are only $12? Is that what it tells me? They're 12 more than the dress. How do I write that if my dress is X? My shoes are X plus 12. Right? Does everybody see that? I bought a dress and I bought shoes. Okay? And so I don't know that y'all have done combining like terms yet, but that's what you would do here. You would actually have 2 X's there. This would be a multi-step equation. So if you didn't get that one to solve, it's okay. But you should have had the dress plus $12 equals the total of 118.